friends and students. Today we have question that borders on latent heat. Yes, today we have today's question borders on latent heat. But before we go on to solve the question on the board, I want to say one or two things about this heat. I want to just tell us, in case we don't know, that we have two types of heat. Basically, two types of heat that we study under heat. The first one is called specific heat capacity. I don't want to say much on that because we don't have it today on the board. But the second one is latent heat. That's where I want us to dwell. I want to talk about the second one, which is the latent heat. And what is latent heat? Latent heat is simply the heat that changes matter from one state to another. We know that we have three states of matter: solid, liquid, and gas. Yes. The work of latent heat in any object, in any matter, is to change that matter from solid to gas, or from gas to liquid, or from liquid to whatever. That is to change matter from one state to another. And it does that at a specific temperatures. Yes. For example, if you want to change a liquid, which is, for example, water, if you want to change water to gas, which is vapor, you will do that at 100 degrees centigrade, which is the boiling point of water. But there's one thing again about this latent heat that I want us to know. Latent heat, if it is there, the thermometer will not dictate it. What I mean is that it doesn't bring temperature increase, neither do it bring temperature decrease. If latent heat is working, thermometer don't usually dictate it, thermometer doesn't dictate it, but it will be there working, changing matter from one state to another. Yes. For example, I want to give us an example how this latent heat works before we now solve the question on the board. For example, you have oil that's solidified, maybe red oil or groundnut oil, that block that's solidified. You want to melt it. You put it in inside pot. Put it on top of fire heat. Yeah, you find out that within some few seconds that the oil is on top of the fire. If you put your hand inside the oil, it will be as cold as it was when you put it. But you find out also that the oil has started melting. It is melting, but the temperature has not increased. But it has already started melting at the same temperature that it was when you put it. Yes, that's what I mean by latent heat. What happened there is that the latent heat of that oil has started working to make the oil at the same temperature. Yes. So what am I saying? What I'm saying is that latent heat is the heat that does the work of changing matter from one state to another without changing temperature at the same temperature. And it must be either at its melting point, boiling point, freezing point. It must be at a specific temperature. It doesn't change with temperature. That is latent heat for you. I hope you understand something about latent heat. That latent heat is simply known in physics as hidden heat. It is hidden, but it's doing significant work. And what is this significant work? It changes matter from one state to another without changing temperature. Okay, let's take the question on the board. Now that you have known what latent heat is all about, the question says, the melting point of a solid is given as 80 degrees Celsius. If 10 raised to the power 5 joules of heat energy is required at this temperature to melt 10 grams of the solid, the specific latent heat of fusion of the solid is... This question is telling us that there is a particular solid. And that solid, if we subject it to the temperature of 80 degrees Celsius, it will begin to melt. That is why it is called the melting point of the solid is 80 degrees Celsius. The question goes further to tell us that this quantity of heat, which is 10 raised to the power 5 joules of heat, is required to melt 10 grams of this solid. And the question now asks us, if that is the case, what is the latent heat of this solid? First of all, let's write out the information, which is the data given to us in this problem. I'll write data, which is the information given to us in this problem. The first information I see is 80 degrees Celsius. 80 degrees, and 80 degrees Celsius is the temperature. So I write temperature, which is denoted by theta, is equals to 80 degrees Celsius. This 80 degrees Celsius. What other information? I see 10 raised to power 5 joules, which is the quantity of heat that is required to melt 10 grams of this solid. So I write quantity of heat, which is denoted by H, is equals to what? 10 raised to power 5 joules. I write it. 10 raised to power 5 joules. Did they give us any other information? Yes, I see 10 grams, which is the mass of the solid. I write mass denoted by M is equals to what? 10 grams. 10 grams. Okay? Any other information? No. So what do I do now? Let's write out the two formulas for quantity of heat on thermal energy. Let's write it out. Formula for quantity of heat on thermal energy is, let me write out the formula. The first one is quantity of heat, which is H, is equals to mc theta. While the second one is quantity of heat, same H, is equals to ml. These are the two formulas of quantity of heat in thermal energy. Now we choose between these two formulas which one to apply to solve the problem. And we start like this. We are giving H here, which is quantity of heat. Yes, we have quantity of heat here, and we have quantity of heat here. So here is H, and here is H also. Okay. We come to M, which is mass. Are we giving any mass here? Yes, this is mass. So we mark it. We come to C, which stands for specific heat capacity. Are we giving any specific capacity here? No. So we mark it bad. We come to theta. Are we giving theta? Yes, this is theta. Okay. So in this first formula, we are giving everything except C. Okay. We go to the second formula. H, we are giving H, yes. Okay. M, we are giving M, mass. Okay. L, are we giving L? No, but we are asked to find the L. L stands for latent heat. So we use the second formula because we are giving this, asked to find this. But in this first formula, you are giving this, but you are not giving this. So we use the second formula to solve the problem. So I will say, let us solve it here. Apply this second formula. I will say quantity of heat H is equals to ml. I'm using this second formula. So what do I do now? I'll substitute these values that are given to us into this formula. I'll start from the first one, which is quantity of heat. What is the quantity of heat given to us? The quantity of heat given to us is 10 raised to power 5. So I'll write it under this H. It will be, I'll substitute 10 raised to power 5 here. It will be 10 raised to power 5. This 10 raised to power 5 is equals to, put this equals to M, which stands for mass. What is the mass given to us? 10 grams. But you know that gram is not the standard unit of mass. So I will change this 10 gram now to kilogram before I will use it. And how do I change it? I will divide this 10 gram by 1000. So it will enter kilogram. So I will say, let me do it here. So I say 10 divided by 1000 will give us what? It will give us simply that this will be 0.01. So that I will now write the mass now to be 0.01 instead of 10 grams. So I'll write here 0.01. Put my times, that's an invisible times here, okay? L stand for the latent heat. Did they give us any value for L? No. That is what we are solving for. The question says the specific latent heat of fusion of the solid is, so L stand for latent heat, and you do not know it, so we still write it there, L. That's what we are solving for. If I continue, I'll write something like this. This 10 raised to the power of 5, I'll write it out completely, and it will be 1. I'll write this 1. Now come this 0. 1 0, 2 0, 3 0, 4 0, 5 zeros is equals to 0.01 times L will simply give us 0.01 L. 0.01 L. Because we are solving to get the value of L, we stand for the latent heat of fusion of this solid. I will make this L now the subject of the formula so that you'll be able to calculate it. So I will write L, this L. L. Put this equals to what? I'll write this number. 1 0 0 0 0 1 2 3 4 0 divided by what? Number with L now will come down, divided by this number 0.01. And if I evaluate, I will get what? Let's evaluate it first. I evaluate, I say 1 0 0 0 0 0 divided by 0.01 give us what? 1 2 3 4 5 6 7 10 millions. Give us what? 10 millions. So I write L. This L now is equals to 10 millions. 1 2 3 4 5 6 7 joule kilogram per 1. Yes, the latent heat of this solid is 10 million joule kilogram per 1. But if you don't want to deal with it, if you don't want to leave it with all these zeros, you can simply convert it to standard form, and it will be L finally now is equals to 1 times 10 raised to power what? Check out. I'll count from here, from this end. 1 2 3 4 5 6 7. This way I put points. Okay, it will be 1 times 10 raised to power 7, because I counted 7 times. Joule kilogram per 1 finally. So the value of the specific latent heat of fusion of this solid is 1 times 10 raised to power 7 joule kilogram per 1. I hope you understand. You understand very well. This is a cheap question on heat, and it is an exam question. Yes, it's an exam question. Thank you for watching.